Students, welcome to today's class. We shall be discussing the angular motion. The angular motion. We say when a body rotates about an axis, it is said to have an angular motion, like a shaft or a disc. Once it is rotating, we say that it possesses an angular motion. Now, let us look at the run, noted by run. We are saying a run, it is the SI unit of angular displacement. It is the SI unit of angular displacement. It is the angle subtended at the center. The angle subtended at the center of the circle by an arc whose length is equal to the radius of the circle. So if you have a circle, and an angle theta, this arc length is equal to the radius, the arc length is equal to the radius of the circle, then the angle subtended is in rand. Then from there, let us discuss on the length of an arc, the length of an arc. The length of an arc is given by phi or the angle theta or the rand subtended at the center is equals to the s displacement over r radius. Now, to make s the subject of the formula, to get the arc length is equals to theta r or r theta. That is how you get this is the arc length, this is the length of the arc divided by this the radius of the circle, the radius of the circle. So s, the displacement we are saying is given by s is equals to r theta. Then you need to note that for a complete revolution, it is given by, or the arc length is given by 2 pi r, the circumference of the circle, 2 pi r, which is equal to the range or 360 degrees. So we are saying to get the so we are saying 2 pi r is equals to the distance or the arc length s. Then, and we are saying which is equal to, we are saying also s is equals to r theta. So 2 pi r is equals to r theta. To get the theta, it means that it is given by 2 pi r over r. So r will go, then you get the rand is equal to 2 pi. And this one, for one complete revolution, we say that for one complete revolution, for our complete revolution, it is equal to 360 degrees, which is equivalent to now the 2 pi. The 2 pi. Now let us that is 2 pi rand. So if you note this one, 360 degrees is equal to 2 pi rand. Let us do an example. We are told example 1 here. We have an example 1 here. A rotary of diameter 560 millimeters turned through an angle of 150 degrees. Calculate the distance moved by a point on the tire and then on the wheel. Now, solution, we know that 360 degrees is equals to 2 pi, uh, 2 pi in range. What about 150 degrees? Now, when you cross multiply that, you get that 150 all over 360 times 2 pi. When you key in your calculator that one, remember in your calculator there is pi, you get 2.618 rand. 2 point. In rand, you are told to calculate the distance, bounded by a point. Now, to get the distance S or the displacement, we are saying is given by r theta. Is given by r theta. Now, we have the radius r. This is the diameter 350. So it means that is 560 divided by 2 to get the radius is 280. So to get S is the radius 280 times the range or the range 2.618 rand. Now you get this one to be 733 millimeters. Is in millimeters. Now that is one of the examples that we have. Now let us move to the angular velocity. Angular velocity. This is the rate of change of angular displacement with time. Angular velocity is the rate of change This is the rate of change of angular displacement with time. It is denoted by the letter omega and Greek 1 omega. It is denoted by Greek 1 omega, and the SI unit of angular velocity and the SI unit is in rand per second. The rand per second. Now we are saying omega is given by rand divided by second. Now you need to note that for a number of n terms, the omega is equal to 2 pi n over 60. This is rand per second. That is for a number of n terms. Now, we have an example there. We have an example here. You are told a shaft has an angular velocity of, so we are given the angular velocity to be 125 rand per second. Find the time they will take to make 350 complete revolution. Now we know the omega we are given. We are given the n, the number of turns, 350, and you know to get beta, you can get beta from that, where we are saying beta is given by 2 pi n, which is equal to 2 times pi, 2 pi times 350, 2 pi times 350, which will give you 22 rand. 2 rand. Now, and you know omega is given by 5 alpha t. Remember, you are going to create t. You are creating the t. Now you need to make t the subject of the formula. You make t the subject of the multiplier by multiplying here times t, here times t. So you get. Remember, we are making t the subject. T that is equals to phi. Now we define rho by omega, we define rho by omega. So T is equals to the half of theta, or in rand, divided by the omega. Now, T, this is, we have our omega, our theta here is 22,000 divided by our omega there is 125. This one, when you key in your calculator, you get 17.6 seconds. 17.6 seconds. Now let us try this one. Let's try this other one. This other example up there. You are told calculate the angular velocity in rand per second of an engine flywheel when it is rotating at 2,800 revolutions per minute. Now you need first of all to work with what you are given. You work with what you are given. Now you can say you are given calculate the angular velocity in rand per second rotating. So you know omega is given by 2 pi n over 60 rand. Now n you are given n, the revolution, that is 2,800 revolution per minute. So then you are told to calculate, you calculate the angle, the angular velocity, So angular velocity, omega, is given by 2 pi times 28 and divided by 60. Now you get your angular velocity to be 293.3 rand per second. Now next, I want us to discuss about acceleration, or the angular acceleration, for the angular acceleration. Angular acceleration Angular acceleration is the rate of change of angular velocity with time. The rate of change of angular velocity with time. It is denoted by the letter alpha. It is denoted by the letter, this and this one, alpha. And we are saying the SI unit of angular acceleration. The SI unit of angular acceleration is in rand per second squared. That is the SI unit of angular acceleration. Now alpha is given by omega 2 minus omega 1 divided by the time t taken. Now where omega 2 is the final velocity, omega 1 is the initial velocity, and t is the time taken. Now in our next class we shall discuss about the equation of angular motion, and we probably will do one example on how to calculate the angular acceleration. Thank you, and we shall continue.